Alright, application of exponents on logarithms, lesson 10 practice test. Again, these videos are for study purposes only. I try my best to minimize my mistake, but it will happen. I try to show and explain most of my steps. These videos might be long, but hopefully they will be helpful. Okay, the exact value of log base 4 of 15 or 16 is. So what it's saying is 4 to the power of what is equal to 16? Or log base 4 of 4 to the power of 2 is equal to 16. So, no, oops, it's equal to what? So the answer is 2 because 4 to the power of 2 is 16. The magnitude of an earthquake that is 100 times as intense as an earthquake of magnitude 5.5 on the Richter scale is. So 100 is 10 to the power of 2. So 5.5 plus 2 is equal to 7.5. 2 is C. 3. 2 log base n of x equals 16. So that means log base n of x is equal to 8. Divide both sides by 2. Okay, now what is x? Well, we have to convert it to the exponential form. So log base a of y. So x is equal to base to the power of 8. So n to the power of 8. So 3 must be a. So again, just use this formula right here. 4. The population of our Alberta town is decreasing at 5% per year. So that means it is 95% of the population stays there. So that means it is being multiplied by 0.95 to the power of n. Okay, what equation can be used to determine the number of years? So this is my b value. My a is the initial value, so 25,000 times 0.95 to the power of n is equal to 15,000. So the answer is going to be B. Wait, I did read it wrong. Answer is D. The approximate value of log base 5 of 31 is. So I know that log base 5 of 25 is equal to 2. And log base 5 of 125 is equal to 3. So it should be way closer to 2 than to 3. So log base 5 of 31 is going to be equal to 2.1. Okay, if log base b of p is equal to 4 and log base b of q is equal to 2, what is log base b of p times q to the power of 3? So we're going to use the log law. We're first going to use the multiplication law. So log base b of p times q to the power of 3 is equal to log base b of p plus log base b of q to the power of 3, and which is equal to log base b of p plus the exponent can be moved to the front, so 3 times log base b of q, which is log base b of p is equal to 4 plus 3 times log base b of q, which is equal to 2. So 4 plus 6 is equal to 10. So the answer is 10. What is the solution of this to the nearest hundredth? Well, am I supposed to use a graphing calculator? Like, I could just graph it and then find the answer, but maybe I'll just do it algebraically. So natural log of 8 to the power of 2x minus 1 is equal to natural log of 16. So take a natural log of both sides. 2x minus 1 times natural log of 8 is equal to natural log of 16. Expand 2x natural log of 8 minus natural log of 8 is equal to natural log of 16. Okay, add both sides by natural log of 8. 2x natural log of 8 is equal to natural log of 16 minus natural log of 8. Divide both sides by 2 natural log of 8. X is equal to natural log of 16 minus natural log of 8 over 2 natural log of 8. Okay, so if you graph this, this will be much easier. Okay, let me go to my calculator. Okay, what did I say? Natural log of 16 minus natural log of 8 divided by 2 natural log of 8, which is equal to 1/6, which is equal to 0. I did something wrong. Alright, give me 1 second while I figure out where I did. Alright, it's 9:30. It must be getting very late because here I'm supposed to add natural log of 8 on both sides, and instead of I subtracted. So small mistake here. Now let's go back to our calculator. So I just graph it to confirm my answer. So let's just retype it in, except for this time let's actually type in plus. Okay, so convert to a decimal. Oops. So 7 divided by 6 convert decimal, 1.17. 1.17. Alternatively, graph it. So here I just graphed it. Y is equal to 8 to the power of 2x minus 1, and y is equal to 16. Okay, second calc, intersect, enter. 1.17, exact same thing. Okay, if log base 25 of x is equal to 5, then what is x? Well, it asks you so if you convert this to a exponential form, it is basically 25 to the power of 5 is equal to x. 6 is d. Or if you don't know what to do, just plug each of these into our calculator. 7 expresses as a single log. What is this? So this 4 can be moved to the exponents first. So log p minus log q to the power of 4 minus log r. And every time I subtract, it means divide within log. So log base p over q to the power of 4 times r, which is a. So 7 is a. 8. If p over q is equal to 25, then what is the value of this? Well, subtraction means division within logs. So log base 6 of p over q, which is equal to log base 6 of 25. Plug this into our calculator. If you have an older calculator, you have to do natural log of 25 divided by natural log of 6 by using the log change base formula right here. But you have a TI-84 or higher, you can just use this alpha F2 and log base. Log base 6 of 25 is equal to 1.796, rounds to 1.80. Okay, in the equation what is the value of x? So again, we should use our exponent to convert this to an exponent. Okay, so what is this? So my base will become my base. So x to the power of 2 over 3 will equal to 64. So what to the power of 2 over 3 is equal to 64? Well, let's take this to the, take this to the power, so we can just raise both to the power of 3 over 2, and then they should cancel out. So these two exponent of exponent will cancel out. So nothing happens. So this is just x. 64 to the power of 3 over 2 is 64 to the power of 3 over 2 is 512. Alternatively, do log base x of 64. Log base x of 64 is equal to 3 over 2. And then calculate the intersect. The intersect is going to be way on your x-axis that way. So my x max, I'll change to 600. Second calc, intersect. So is it realistic to do it? Oh no. Log base x of 64 is equal to, it's 2 over 3. Haha. Imagine if I can type in things correctly. So this intersect is going to be way over here. Second calc, 5 for intersect. Inter. So yes, 5 and 12. So a lot of these questions can just be done with a calculator. If log base 6 of y is equal to t, what is log base 6 of 36y? So we're going to use our power law. So this is log base 6 of 36 times y. So 36 plus multiplication within log is addition between logs. Okay, what is log base 6 of 36? Well, it is 2. And what is log base 6 of y? Well, it is t. So it's going to be t plus 2. So 9 is going to be D. Use the following information to answer the next question. A student is trying to solve this. The student's work is shown below. So this guy took the log of both sides. This guy forgot to add a bracket in front of this. Okay, and because this guy forgot to add a bracket, every step below is wrong. So the first error occurred in line A. Just for clarity's sake, let's see if this guy did any other errors. The rest seems fine. It's just the forgotten to include the brackets because these exponents have hidden brackets around them. 11. A privately owned music store is selling off all its compact discs so it can focus on selling DVDs. During the first week of the sale, all compact discs are priced at $18, and each week the compact discs are reduced by 12% of the previous week's price. So 12%, that is 0.12. What decimal of the price is left? 0.88. So if I want to do an exponential formula, 18 times 0.88 to the power of x. So when x is equal to 8, what is the value? Or sorry, when x is equal to 7, what is the value? So 18 times 0.88 to the power of 7, which equals 7.35, and that makes the answer 7.36. 11 is C. I guess there's a little trick here. It says during the first week of the sale, it is at 18 bucks each. So during the 7th week, that means I have to subtract 1. So $18 is week 1, so that means it is 0.88 to the power of 0. So I actually have to do 0.88 to the power of 6. I hate these type of questions. So 8.35. 8.36. So yeah, so 0.88 to the power of 0, this is week 1. 0.88 to the power of 1, this is after week 1. Discount, so it is week 2. So you see the number of the exponent is always 1 less than the number. So in the week 7, that means I will have 0.88 to the power of 6. That's why I did 0.88 to the power of 6. Okay, 12. Jane would like to visit her family in Australia. She figured that she will need at least $9,000 for plane ticket expenses. She goes to a local bank in Calgary to open a savings account. After some thought, she decided to deposit $7,500 into an account that pays interest at 8% per year, compounded quarterly. The number of compounding periods it takes her to reach at least $9,000 is. So I want compounding periods. That means the interest rate is 2% per period. So 75, so 9,000 is equal to 7,500 times 2%. So that means it adds to the 100%, which means the decimal right here is 1.02 to the power of x compounding periods. Okay, so can graph it, you can solve it by hand, whatever, I'll just graph it. So 9,000, 7,500 times 1.02 to the power of x. So I'll just go to table to find out when is my, at what, so at least 9,000, so I wanted to reach 9,000. I don't want the one before 9,000. So this is 8963, so this person needs 10 compounding periods for it to reach 9,000. So 12 is B. 13. Josh borrowed $2,000. Interest was charged at a rate of 3% per year, compounded semi-annually, so every 6 months. So that means 1.5% interest rate per annual or per 6 months. He did not make any interim payments and paid the loan in full at the end of the loan. The interest charged was $253. The length of the loan was. Okay, so what is my thing? My thing is so 2,000 times 1 plus so 1.015 to the power of x 2x, because there's 2 compounding periods per year, and then you subtract the original, where you can add it to 2253 is the final. So I want to see what this is equal to. So this is my total paid, so 2253. 2253, it is equal to 2,000 times 1.015 to the power of x. Again, let's go to the table, see how many years this is equal, or see how many x is equal to. So x is equal to 8, it lines up exactly. So 13 is, wait, what? Compounding semi-annually. Semi-annually means every 2 years. Oh, I missed a 2 here. That's why it was so weird. So it's a 2x. Second table, so at 4, it is exactly the same. So 13 is B. Okay, the ball is drawn from a height of 5 meters. After each bounce, the ball rises to 75% of its previous height. So 75%, so that means the maximum height. So 5 meters times 0.75 to the power of x. So that means after 1, so to start off you're at 5, so that means 0 bounces. And then after 1 bounce, it will be 0.75, so times 10 to the power of, or times 0.75 to the power of x, which is correct. So 6 times, it shows 5 times 0.75 to the power of 6. 5 times 0.75 to the power of 6 is 0.89 meters. So 14 is C. 15. The number of bounces it takes to reach a maximum height of approximately 5 centimeters is, so 5 centimeters and 5 times 500, because I want centimeters, times 0.75 to the power of x is window. X max is maybe 30, 20 maximum. I just go 25 to be safe. X minimum is 0 because it cannot go backwards. Y minimum is 0 because it cannot go into ground. Y max is or because it cannot go below, cannot go bounce inside the ground, and Y max is 500. Okay, yeah, graph it. So when do these two lines intersect? It looks like somewhere over here. Second calc, 5 for intersect. Enter. So around 16 bounces. 15. The formula I1 over I2 is equal to 10 blah 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 can be used to compare the intensity of two sounds measured by the decibel. How many more intense? Okay, so this is the intensity. It's a sound of a student talking, 60 decibels, compared to a student whispering, 30 decibels. So 10 to the power of 60 decibels, 60 minus 30 divided by 10. So 10 to the power of, so that 30 divided by 10 is 3. So it is 1,000 times more intense. 15 is D. Blah blah is under next two questions. Okay, if lemon juice have a pH value of 2.5, then to the nearest whole number, how many times more acidic lemon juice compared to tomato juice? What is tomato juice? 4. So 4 minus 2.5, 10 to the power of this. So 10 to the power 1.5. 31.6 times, so 32 times more powerful or more acidic. Since X has a solution pH of 9.2, solution Y is 20 more times alkaline than solution X to the nearest tens. What is a solution Y? So 9.2 plus log 20. 10.5. Okay, it's the exact solution of this equation. If you don't know how to do this, graph it, type in each of these in your calculator to see what the answer is. But they're using the common log, so we should use common log. So log of 2 to the power of 4x is equal to log of 3 to the power of x plus 1. Use log law. 4x times log base log of 2 is equal to x plus 1. Make sure this is in brackets. Times log 3. Expand 4x log 2 is equal to x log 3 plus log 3. Move everything to this side. So 4x log 2 minus x log 3 is equal to log 3. Common factor of x, 4 times log 2 minus log 3 is equal to log 3. Divide everything by this in the bracket. X is equal to log 3 over 4 log 2 minus log 3. So what is the answer? A. Keep going. The exponential decay blah 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 exponential function can be used to solve problem involving time d. Okay, so the radioactive substance lose 90% of radioactivity in 10 days. So that means 10% is left. What the equation I use to determine the half-life? Well, so 10% is left, so A naught is equal to 100. A is equal to 10. And then time is equal to 200. I don't know what the P is, so 10 is equal to 100 times 1/2 to the power of T 200 over H. I don't know what the half-life is, so And in this case, they want the half-life to be in P instead. It's kind of weird. So 17 is A. 18, in a population of insects, 32 insects increase to 500 insects in 2 weeks. The doubling time for the population of insects when nearest tenth of a week is. So again, it's something like this. So 500 is a final, 32 is the initial. Doubling means it is 2 to the power of 25 weeks divided by P. So I have to find out what P is. Don't really want to solve this by hand. Well, I guess I can just plug in P is equal to this and then find out. So if you are not sure what to do, plug in these numbers, see what makes the most sense. 500 is equal to 32 times 2 to the power of 25 divided by x. Okay, my y maximum, okay. So I want to find that intersect right there. I thought this is increasing. 32 times 2 to the power of 25. Oh no, this is 25, so I want to find P. So again, second calc, 5 for intersect, enter. 6.30 weeks, so 18 is C. Cobalt 60 is radioactive. In the radioactive CRB, 10 grams of cobalt 60 decays to 4 grams in 7 days. What is a half-life? Into the nearest tenth of a year. So half-life, so starting amount is 10, ending amount is 7, half-life is 1/2 to the power of, I want 4 grams in 7 years, so that means my time is 7, and my period, I don't know. So same idea, 7 is equal to 10 times 0.5 to the power of 7 to the power of x. This graph is going to look really weird. I can still second calc intersect. You don't really have to see it to calculate it. Oh, maybe not. 700. Oh, 7. Second calc, 5 for intersect. Enter. Okay, 13.6 years. Huh. Man, I really can't read, huh? Well, it is 10 p.m. Maybe I should go home. Now 7 is 4. Where did 7 from? Oh, in 7 years. Okay, so starting is 10 grams, ending is 4 grams. Second calc intersect. Enter. 5.3 years. 19 is D. 20, the value of a painting doubles every 20 years. If the value was 4,000, then what is the approximate value on July 10th? Okay, so I want the y is equal to, starting value is 40k times double, so it is 2 to the power of time divided by period. So what is doubling period? 20. So how many years did it pass? No, it is negative 12 years. So t is equal to negative 12. So 4,000 to 40,000 times 2 to the power of negative 12 divided by 20. It is negative 12 years. So from 2000 to 2012, it is it is 12 years. So 26, 390, 20 is C. So we also work backwards, but most of the time we only talk about things going forwards. Okay, written response. Holy, it's long. A grade 12 student correctly solved each of the following exponential equation problems as a review for an exam. In this student's original attempt to solve problem 1, one error is made. The student's original sequential shown state the step in which the error was made. So the error was made in step 1 because you had to do bed math, so you had to do exponents before you multiply. Okay, divide both sides of the equation by 2 and algebraically using common base show that x equal to 2 is the only correct solution to the power of 1. Okay, so 2 times 4 to the power of x is equal to 32. So 4 to the power of x is equal to 16. Common base means I want common base of 4, I guess. So 4 to the power of x is equal to 4 to the power of 2. Therefore, x is equal to 2. Okay, algebraically, using logs to show that x equals 7.75 is the only solution to the second problem. Okay, so that is a second problem. 2 to the power of x minus, I copy it down, so take the log of both sides. Natural log of 2 times x minus 3, or 2 to the power of x minus 3 is equal to natural log of 27. Exponent law, x minus 3 times natural log of 2 is equal to natural log of 27. Expand the left hand side, x natural log of 2 minus 3 natural log of 2 is equal to natural log of 27. Add both sides by 3 natural log of 2. X natural log of 2 is equal to 3 natural log of 2 plus natural log of 27. Divide both sides by natural log of 2, so this part cancels out. We get x is equal to 3 natural log of 2 plus natural log of 27 over natural log of 2. Okay, 3 natural log of 2 plus natural log of 27 divided by natural log of 7. 2.76. What? That's not good. So I took the natural log of both sides. I used exponent law. I expanded x natural log of 2 times negative 3 natural log of 3, so natural log of 27. Add both sides by 3 natural log of 2. Okay, it works. Divide both sides by natural log of 2. Oh, I rolled it down too ugly. .75. Okay, last one. Algebraically, using logs or a common base, show that x is equal to negative 4 over 5 is the only correct solution to problem number 3. Okay, so 9 is 3 to the power of 2, and then to the power of x plus 2 is equal to 1 over 27. So 1 over 27 is equal to 3 to the power of negative 3. So 3 to the power of negative 3 to the power of x. Okay, use power law. 3 to the power of 2 times x plus 2 is equal to 3 to the power of negative 3x. Okay, so if the base is the same, both are 3, that means the exponents must be the same. That means 2 times x plus 2 must equal to negative 3x. expand 2x plus 4 is equal to negative 3x. Add both sides by negative 3x, or add both sides by 3x. We get 5x plus 4 is equal to 0. Subtract both sides by 4. 5x equal to negative 4. And then x is equal to negative 4 over 5. And of course, I can do the same thing with a common log. Maybe I'll do it over here. Just need a white sheet of paper to write it on. Okay, let's see. So natural log of both sides. Yeah, it's really getting late. So I'll just skip home steps maybe. X plus 2 times natural log of 9 is equal to natural log of 1 over 27 times x. Expand both sides. X plus x natural log of 9 plus 2 natural log of 9 is equal to x natural log of 1 over 27. Move everything to one side, move this to the other side. X natural log of 9 minus x natural log of 1 over 27 is equal to negative 2 natural log of 9. Common factor of x, natural log of 9 minus natural log of 1 over 27. Divide both sides by this in the bracket. Okay, type that in your calculator. Negative 2 natural log of 9 was in the denominator. Natural log of 9 minus natural log of 1 divided by 27. Calculate negative 4 over 5. Okay, that's it for application of exponents and logs. Probably one of the weirdest units, or the hardest units. Combines quite a few things with what you had learned before. Alright, that's it. Hope you learned something. Goodbye.